So we are looking at the crafty coloring problem, both easy as well as the hard version of this problem. Uh, the major difference between both of these is the constraints. Uh, so for the easy version, the sum of n cross m across all tests is bounded to 2 into 10 is to the power 5, and for the hard version, each of them individually can be 10 raised to the power 9, right? So what does this tells us? So this line tells us that we can perform operations till the time complexity of big O of n into m, right? Because that will be covered under these many iterations. According to these, the test cases will be designed, which basically means that the test cases will be light, right? And for the hard version, you'll have to come to the most optimal solution. Okay, so let us see what the problem says. The problem says that Alice and Bob want to play a game on a grid with n rows and m columns. The cell at the interaction of ith row and jth column is denoted by I, comma j. Initially, all cells of the grid are colored white. On a player turns, the following happens. So, yeah, the first thing to remember, all of the cells in the grid will be white. The first player must choose a cell I, comma j that is colored white. If no such cell exists, the game end immediately. If it is Alice's turn, then all of the cells that share a row and column with I, comma j will be colored red. And if it is Bob's turn, all of the cells that share a row or column with I, comma j will be colored blue. Okay. So another information to remember: formally, all cells x, comma y such that x equals to I or y equals to j will be colored. So this will be at the end of the game. You are given a cyclic string S of length k that contains only the characters A and B. This string describes a sequence of which player will make which move. So let's say if the string is A, comma B, the first move will be made by Alice, then the second will be made by Alice, and the third will be made by Bob. What will be the case if the matrix will not be filled after the string ends? The string describes the sequence of which player will make which move. That is for an integer I greater than equals to 1, right? So if this happens, right, which means that I is greater than equals to 1. So if I mod k plus 1, so what does this mean? S of I mod k plus 1. So let's say k is 3, right? And we arrived at the position where now the k is equals to 4, let's say, right? So 4 mod k will be 1 plus 4 mod k will be uh, what 4 mod k is 3, then 4 mod k will be 1, right? So in that case, so what they're suggesting us that in the case when I will be greater than the length of uh, the string array, let's say this is the string, right? And if let's say the length of this, mm, we can take any, let's say let's just AP. So these are very small length strings. If the length of these is k, okay, let's say the length is k, then what is given? So I will be starting from 1, right? I will be starting from 1. So I will be 1, 2, 3, 4, 5, 6. There will be cases when I will become 7, right? What will happen in those cases? si mod k plus 1, which means s of 7 mod k, which is 6, plus 1 will be equals to 8, and which means the bob will make the next move if it is equals to b, right? If this is equals to a, then Alice will make the ith move, and if this is equals to b, then Bob will make the uh, ith move, which means that this will be happening in the cyclic order, right? Which is very clear. This was an easy thing to understand. The winners of the game is the player with more cells of their color, right? If both players play optimally, find the winner or decide that the game will end in a draw, right? So, how will they play optimally? That we have to decide, right? All we know is that Alice and Bob, when it will be their turn, uh, they will be selecting the cell which is white, right? This is the condition that we know. Okay, so I think these test cases are very small. We can take some test case of our own, right? So let's say we have, so okay, so let's say this is some matrix. Uh, so n here is 4, and m is 1 2 3 4 5 6, and m equals to 6, right? So generally, uh, make it a rule of thumb that in most of the cases where we have to fill something into the matrix, we generally move backwards, right? If it is not a dp problem, so we move backward. What does it mean by we move backward? Imagine what will be the last turn. Okay, so what will be the last turn? Last turn will be when everything will be filled and a random cell, let's say here, it will be remaining, right? Or maybe some more cell here and here can be remaining to be filled, but like if we fill this one, then if some cell is remaining here, it will be filled automatically. Okay, so and in the last turn, whatever the initial color of these, let's say, so okay, let's assume that Alice have red color and Bob have green color, right? So the last move will be, uh, let's say Alice has the chance to fill at last. Then all of these cells will be red, right? No matter what the initial color was, the color will be overridden, right? So this is one of the observation. Let's say before that, it was Bob's turn and he selected this. Okay, he selected this. So this will be the row and column, and all of these cells will be green, right? Irrespective of what the previous color was. Let's say before that, the previous color for this cell was red, but now it doesn't matter because after that, Bob has chosen to select this row and this column. So that will be colored differently, right? And that will be finally green, and it doesn't matter what the previous color was. So let's try to make an assumption here that once the row and column is assigned to some particular color, uh, that row will only be changed once another once another cell is selected, and only in that case some of the assigned colors will be changed. Other than that, nothing will be changed, right? Let's make this assumption. So we know that this color was selected by Bob, and only change uh, in the assignment of these colors will happen due to the cases where the cell will be filled after this one, right? And once one cell is filled, no cell from that uh, pair of row and column can be selected. Okay, so we are reducing a lot of cells in each turn, right? And let's say, how many total number of selections are possible for each of the cases, right? So we have n number of rows and m number of columns. We will be able to select only the minimum of these two. Can you see this? Why? Because in every assignment of color we are uh, in every assignment of color we are trying to occupy one row and one column, right? And if all the rows or all the columns are selected, so does it make sense that all of the, let's say if all the rows are completed, then it is not possible without all the columns completed, right? It is not possible. So we only have minimum of these chances with us. Okay. Okay, so now it will make more sense why we are trying to move backwards, right? So we have some order: a b a c, not c, b, a, something, right? And we know that only minimum of n comma m operations are possible. This we know, right? So we have n equals to 4 and m equals to whatever greater than 4, right? M equals to 6. So only these things are possible. This should make sense now, right? So, and we know that the last assignment will be done by A. Okay, so A will get how many nodes in his uh, account? What is the total number of cells here? N, right? Oh, sorry, M, n minus 1, m plus n minus 1. Does it make sense? M plus n minus 1. This guy uh, kept into his account. Now, B, no matter what B selected, right? B will get, B will try to get m minus n, m plus n minus 1, but as A will be selecting after B, as A will be selecting after B, he will take two of his selected cells, right? One is this one and one is this one. So at the end, he will get this much into his account. Does it make sense? Similarly, what will happen with this guy? This guy will try to capture m minus n, m plus n minus 1 cells, and two will be captured by this guy and one will be captured by this guy. For example, let's try to see again. Let's say he tried to occupy this. Okay, so this guy green occupied this, red, this got occupied by red. Okay, this got occupied by green, and uh, this got occupied by red. So how many? One, two, oh sorry, three. Yeah, one, two, three, and four. One, two. Oh sorry. Yeah, one, two, three, and four. Four cells got occupied, right? So two were occupied by this guy, and two more were occupied by this guy. See, it doesn't matter we are subtracting it here, because and even if the last one is occupied by the same guy, because we are ultimately adding it there only, right? So we'll delete this much from his account, and once he'll get these back, he will add them to his own account, right? So it doesn't really matter. So I think now this problem has become a lot easier, right? What we are doing, we are going back from the last, and we know that these people will try to take more and more points into their account, but whatever the number is remaining, right, after it. So when we came here, whatever the number is remaining after this, let's say there are three more chances remaining after this. So 3 into 2 less 3 into 2 less points will be assigned to this guy, right? Now this intuition is a lot clear. Now I think we all know what we are trying to do, right? So we can now generalize this for this question. General. Now we were like before this we were dealing with one particular test case. Now let's try to generalize, right? Let's solve it using one of the test cases. So we have 3 comma 4 and ba as the string, right? So 3 comma 4, this is our array. 3 comma 4, this is our array, and we have ba as the string. So uh, what conclusion we came to? We came to the conclusion that minimum of the row and the column are the total number of cells, or total number of chances, or total number of selections that can be made iteratively, right? So we can transform the string to this, like uh, first chance will be given to b, and then second will be a, and then again as the string is cycling, the third chance will be given to b, right? So now we know that we will try to take how many into his account, m plus n minus 1, right? But four of them will be taken by the ones who are remaining, right? So m plus n minus 1, let's make this a one variable. Let's say factor, let's say we have some factor variable, right? So this will now have factor minus 4, this will have factor minus 2, and minus 2, and this will get factor. Does it make sense? let's try to code let's try to code this. Okay, let's try to code. Hmm. Let's remove this. After this, we'll try to solve the harder part, and we clearly know, right? Like we have came to a conclusion that there is a pattern. Like we can clearly see a pattern. We are trying to solve this iteratively, but we have to solve this in some sort of an optimized way. First, let's try to solve it iteratively only, right? Okay, what is the input structure? Why solve? Are we solving the easier one or hard one? Yeah. Okay. So what is the input structure? We have L, we have N, M, and K. n and k. The dimensions are good, okay. And then we have a string, right? Yeah, string s. Okay, now let's see what will be the number of steps or selections, right? So number of selections will be minimum of n comma m. It makes sense. And we introduced the variable factor, right? Fact, what was factor? Factor was m plus n minus 1. Okay, yeah. So now we need to see whether we need bigger string or not, right? Whether we need to use the cyclic nature of the string or not. Okay, so if n is if our factor is greater than the size of the string, then yes, uh, we need to increase the size of the string. How much will the increase happen, right? Int I equals to 0, and let's initialize a variable with which will be equal to the size of the string, and we'll make the size of the string equal to the factor, right? While the size of the length is less than factor, what do we need to do? We need to push back this, right? And then we'll take the mod to maintain the cyclicity. Okay, now after this we will have the length of the string as at least equal to the factor. Then how will we be arriving at the answer? Let's say points of a initially was 0 and points of d is equals to 0. Okay, then we will be starting with the factor minus 1, and we'll come to the start. We'll be coming to the start now, and factor will be this will be the length. This is the length, and yeah, mm, length of the string is less than factor. Yeah, so now factor minus 1 is the last character of the string. Okay, factor minus 1 is the last character of the string. If s of I is equals to a, then we'll do something, else we'll do something. Okay, what we'll do when this is a, fact to be subtracted, this will be starting with 0, and how many points will we be adding in each uh, assignment of cell? Okay, so for when the character is a, then the assignment will be added to a. How much will it be? It will be uh, um there should be selections. That is why I was getting confused. I'm sorry for that. Point of A, points of A. This will be added to points of A. And how much will be added to points of A? Factor minus factor to be subtracted into 2, right? Similar thing will be done in the second case. Just the points will be added to B. Does it make sense? If points of A is greater than points of B, then we will be printing Alice. Else, if points of B is greater than points of A, we will be printing Bob, or else we will be printing draw. Let's try to see if this is running. Uh, why are we not? I think I have done some mistake. 322. Hmm. I'm taking three inputs. I'm taking a string as an input. Then we are modifying the string. And we have made sure that it is equal to selections. Okay, time limit exceeded. We're getting some time limit exceeded. Hmm. But still, if the time limit is exceeding, we should not be getting a draw. Let's try to dry run on this 222 and AB. So for this, we have this and we have AB. So we know that 2 plus 2 minus 1, which is 3, is the factor, and we are starting it with 0. So B will be getting 0. Uh, factor minus, yeah, factor minus factor to be subtracted, which is initially 0 into 2. Yeah, 0 into 2. So B will be getting 3, and A will be getting factor, which is 3 minus 1 into 2. Okay, got it. This needed to be factor to be subtracted plus plus. But again, this will not solve the time limit exceeded thing. Okay. Let us try to see if this is working fine for all of the test cases. No, clearly, because this is an IDE. Okay, It has nothing to do with the question, and still it says that the time limit is exceeding, which means that we have done something wrong. If selections is this, yeah, yep, this was the thing that was wrong. So we need to update the length of the string. Sorry for that. Bob, Alice, Alice. Okay, the third one is wrong. Let's try to try them. 342 BA. 342 BA. 342, which means 3, 4, and BA, and the third one will be B. Okay. What is our factor? Our factor is m plus n minus 1, which is 6. So this will get 6, this will get 4, and this will get 2. So clearly Bob is winning. I don't know why we are giving Alice as the answer. Let us see. We selected the minimum. We get the this. Okay, and if selections number of selections is greater than k, then start int I 0. While the length is less than selections, keep pushing this, keep increasing this, and keep uh, modifying this. Okay, and B, yeah, I mod k, and then the length will be increased. So I'm sure the string by this time must be BAB, right? Let's try to check it. BAB. Yep, it is BAB. Then points of A, points of B factor is this. Selections minus 1. Okay. Selections minus 1 will be, what is selection? Selections is 3, so minus 1 will be 2. It is fine. SI is A, then power of A. Although we need to add. What am I doing? Okay. Yeah. Now this should work fine. Bob, Alice, and Bob should be the answer. Let's try to submit. Okay, we got a correct answer. So we made some progress. Now, I'm not sure if I'll be able to reach to the correct solution for the harder stage, but let's try. Okay. Crafty coloring harder version. We know that we have made some observation, and we know that it doesn't really matter like in what order cells are selected. We know how many cells will be added for each of the cases, right? So first let's try to see where we are over calculating and where we can optimize. Let's try to figure that out first, and then we'll see how to optimize it. Okay, now I think this should be fine. This can be optimized actually, but for now let's say, okay, let's optimize each of them. But clearly we know that this doesn't really matter. This is the part where things start to matter, because each of them can be as large as 10 raised to the power 9. Okay, but like what is the time complexity that we are using? I don't think it is. I think we are doing it in big of n only. Will it cause some trouble? Or can we use this? Let's try to first use this and then we'll see. Because we are using big of n, and I think big of n can work for 10 raised to the power 9. I oh god. Okay. Plus plus 11 plus and what else? Is there anything else? Okay. Clearly we need some optimization. Hmm. One optimization we can do here, but that should not be the case. There must be some optimization that is possible here. Right. So I think is this too much? Can we I mod k? Can we do this? We can obviously. Is this this is not this cannot be the optimization that is needed. Yeah, of course. Okay. What is the constraints for k? So k is where are the constraints? We can traverse till k, and we know that. Okay, so what am I thinking here? Let me tell you. So let's say this is some string a b, A, B, B, B. Right. Let's say this is some string. Okay. Then we know that what are the possible cases. That number of selections that we need to make will be so big that we will have to use this again and again and again. Okay. We are aware of this. Right. Then we should be able to make some pattern. For example, this A, right? So we know, let's say that we know we need to make how many iterations? Let's say 3 iterations of this entire string, and then we will be ending here, right? So we'll go 1, then again 2, then again 3, and then this silsila will end here, right? So can we count this? Can we count this? Yes, we can. Yes, we can count. How? So this will be number of these complete rows will be what? Number of selections divided by k. This is basic math. Come on, everybody can understand this, right? And what is this value? This will be selection mod k. Is this very tough to understand? Mod k. No, right? So okay, this we know now. Now what? This means that clearly A is not gonna be the one who will be selecting the last thing, right? A is definitely not gonna be the one. For here, at this part, how much coins will A add to his account? That will be factor minus whatever this is. We need to find some way to calculate this. What this will be? Okay, we'll come to it. We'll come to it. This will be factor minus sum of this plus this. Does it make sense? Then factor minus one row added to previous, then factor minus one row added to previous. Okay. Okay. Now what? We know that there will be couple of full rows. Okay. There will be couple of full rows. There may be an extra remainder row, and there will be the same row remaining. So we need to take care of all these 3 to 4 things, right? While traversing this string once. Okay, so let's code this much for now, and we'll go into the lower level details after it. Okay. So what we'll do, we'll calculate what is this number. Okay, we'll calculate what is the remainder, and then we'll be traversing over just the first row. So I'm trying to break down the problem to make it simpler for you guys to understand. Okay, so let's try. So okay, this is bullshit. Okay, but this will also be the same. Only this logic needs to be changed. Okay, so first let's try to find out the quotient, right? L quotient. Quotient is what? Number of selections that is needed to be made. Okay. number of selections that is needed to be made, and that divided by k, right? What will be the remainder? Same thing, mod k. Okay, now now we know that what can be the cases. If so, now let's try to calculate the number of these complete rows. Okay, what will be the complete rows? LL complete rows. What will be these complete rows? These will be QUO minus 1. Why minus 1? Because we are subtracting this row. Okay, we are subtracting this row. Now, okay, I think we have done our job. There will be one or two more cases. One is, what if QU, oh sorry, what if our quotient is 0? Then we'll only have that remainder row, right? And else we need to uh, handle for complete first row, and with handling those uh, complete rows as well as the remainder row. Okay, so here the iteration will be very straightforward, right? What we'll do here, let's move backwards, as that will be easier to code, right? So factor to be subtracted, this is the same thing that we used in the easier version. What, so what will happen here? If s of I is equals to a, then something, else something. Okay, and this will add the factor minus fact to be subtracted into 2, and this will add points of b plus factor minus fact to be subtracted into 2. Okay, now let's come to the else part. And for here, we we can easily uh, here we can easily initialize this factor to be subtracted to some value. What will be that value? That value will be complete rows into complete rows into what is the length of our string? Complete rows into length into 2. No, complete rows into length. This is the factor to be subtracted. Why is this the factor to be subtracted? See, let's try to see here. So let's say we are traversing the first row, right? So we will be subtracting the factor for each of the rows in the middle. We have calculated what is that number of rows. That number of rows is complete rows, right? So the factor of to be subtracted becomes complete rows into length, right? Okay. Now, yeah, I think we've reached a good stage. So this factor, and also we got to add what we got to add. From this, we will subtract all of this. From this, we will not be subtracting all of this, right? So what is this value? Okay. Uh, this is an unprecedented complication. Okay. What will be the value at this point? Factor minus all this shit. Factor minus something plus. So they will factor into some some value minus some value. Okay. Let's first try to calculate this. What will be the coefficient of factor, right? So there will be some q coefficient of factor, because we need to add this factor for all of these rows, right? I didn't see that in the first place. Then there will be some value that is to be subtracted. Okay, let's first try to calculate this factor. Okay, so these are complete rows. These will be, every time these will be there. Complete, sorry, complete rows plus 1 will be there. And okay, okay. Mm, this is the minimum that will be there. Let's try to now iterate for int I equals to q minus 1, I is greater than equals to 0, I minus minus. Uh, if for here we need to first, let's try to first calculate the n for everyone. Right. That will be better. Now, if this I is less than, if this I is less than the remainder, right? Let's define some points here. Okay, then points will be added, right? What will be the points? Points will be factor. What will be the factor here? What will be the factor here? Mm, remainder minus I, right? Remainder minus I into 2. Now here we have handled for the last remainder layer. Okay, that is handled. Let's check for the other layers. Points will be added with factor into n. Now there is some value that is needed to be subtracted. What is that value? Let's try to calculate that value. So we have handled for this. And this is one of the achievements we have handled. All right. So we know that this remainder will always be there for all the layers, right? So let's say this remainder, what need to be subtracted for this one? What needs to be subtracted for this one? This will be remainder plus this length. Okay. Mm, mm. We need to make a general function. Uh, let's try to generalize this. Uh, let's do some generalization. Let's say we have these. Let's say we have these three lines. Okay, we're not able to see this clearly. Yeah. Let's say we have these three lines. Okay. We are traversing here. Okay. So first, let's try to calculate the number of elements here. So I'm trying each of these independently to make it more modular and more understandable. All right. So, so the last index was k minus 1 and the first index is 0. Let's say this is I. So I plus 1, I plus 2, and we are going till k minus 1 index. Right. So let's say 4, 5, 6. Right. And we are at third. So k minus 1 is equals to 6. So how many indexes are there? K minus 1 minus I, right? 6 minus 3. 3 elements. So here are 3 elements. Elements at right. LL elements at right. What will be the value? The value will be k minus 1 minus I. These will be the elements at right. What was N? Yeah, yeah, we will come to this later. Okay, this we did for the last row. Got it. Okay. Now, no, clearly, for every row, remainder will be subtracted, right? Clearly. So let's check for this row. What will be subtracted? Remainder plus remainder plus the elements at right, right? What will be subtracted for the row above? What will be subtracted for the row above? Remainder plus this row, row plus element at right. Similarly, remainder plus 2 row plus element at right. Is this making sense? So now what do we know, that how many times will remainder be there? All of these things, right? So remainder into number of rows, okay, and actually remainder plus er, both of these things will be uh, both of these are valid for all of these rows. Yeah, remainder plus element at right. Yeah. So remainder, so r into element at right plus r 2r 3r 4r r into 1 plus 2 plus 3 plus 4, which means um, for this we don't have anything. For this we have 1, 2, 3. So actually r so number of rows, or we can say quotient. This is quotient, right? 1, 2, 3, 4. 4 is the quotient. So quotient minus 1 into quotient by 2, right? So can we say that this is the factor that will be subtracted, right? Fact to sub total. What will be this? The into remainder into what? R, remainder into number of rows, number of, actually this is quotient. This is quotient. Quotient, remainder into quotient. What else? What else? Elements at right into quotient. What else? Quotient. This is quotient. Okay, wait. Uh, really. 0, 1, 2, 3. Th- this is the number of elements, right? This is number of elements. So this is length. So length, yes. So length into quotient into quotient minus 1 by 2. This is the total thing that is needed to be subtracted. Okay, I think now we don't need this, right? Now what is the total that is needed to be added? That will be, so we need to add points plus equals to quotient, the number of rows, into factor minus factor to be subtracted. Now if s of I equals to a, then points of a plus equals to points, else points of b plus equals to points. Okay, so this is a very complex code. I'm almost sure that this will not work the one in one go. Kotor. Where have I written that? Factor. Okay, we are getting Bob, Alice, and Bob. Let's try to submit. Wrong answer. Failed on a hidden test case. Where did we go wrong? Elements at right seems correct. Hmm. If quotient is 0, which means we only have the elements at right. Okay. Again, we forgot to add it. What the hell am I doing? Again, something is wrong. Yeah. This should not be K. Why is it K? This should be remainder and with no one. Why is it K, bro? Why was it K in the first place? I don't understand what I keep doing. And this should be equals to remainder, right? This should be equals to remainder, right? I think so. No, this should not be. Okay. Why it should be less than remainder? You know what? Irrespective of this has to be true, right? This has to be true. So now we don't need to do this. Oh, where we are getting wrong answer in the first one. So, so the remainder for the first one is 0, right? Okay, there's something wrong with this. So if the remainder is 0, why are we even calculating it if the remainder is 0? It should not be calculated. If the remainder is 1, then it should be calculated for. If the remainder is 1, it should be calculated for remainder minus 1. Yep. Got it. To match the indexes. Mm-hmm. Now, okay, we got the points of A and B. We got the points of A and B, and Mm. So if the quotient is 0, or if it is not 0, 0, n is nowhere used. Let's remove this from here. Okay, why it is here now? Okay, we got the now. So this remainder into the quotient. Yes, remainder into quotient makes sense. 1 into quotient, yeah, it makes sense. But remainder. Yes, it makes sense. Elements at the right, does they make sense? Yes, they do make sense. Why? Why do they make sense? Like if we are at third index, fourth, fifth, sixth. Okay, let's say 0, 1, 2, 3, 4, 5, 6. This is the third, fourth, fifth, sixth. So these will be added one time. But yeah, but this need to be multiplied with 2, right? Why are we not multiplying this with 2? Okay. Elements at right into question. Why are we multiplying quotient here? This doesn't make sense at all. Plus 1 plus 2 till question minus 1. Yeah, let's try. Again, something's wrong. What's wrong with the. What is the problem now? Remainder into this will be remainder. Okay. Question is not 0. The remainder equal to the 4 rows we have. Remainder minus remainder. Then remainder into question. Correct. Elements at right will be used one time. Length this will have 0. 0, 1, 2, 3. 0. So 1, 2, 3. 3. So the remainder was 4, right? 4 into 3, 12, 5, 2, 6. 6. 6 is correct. Q. Q has 1. Into length. Yeah, it's correct. This shit. These. These minus 2. Yeah, it is correct. What am I doing? There's maybe up and down. फालतू चीज़ें ट्राई करते हैं वो पॉइंट के नहीं इस चीज़ को Quotient into factor. Are we sure quotient into factor? Hmm. So factor or factor. Talk. Again. This will have some things to subtract. What will be those things? Hey. Mm, this will be subtracted from everything. Wait. No. This will be subtracted from everything, right? So yeah, that is what we are doing. We are subtracting it from everything. No, we are not. Or we are. Are we or are we not? 1, 2, 3, 4. Of question into factor into no, just this much. Question into factor. This guy. Hmm. Remainder minus L, right? Remainder plus right. This will be subtracted. Remainder plus row into right. Remainder plus 2 row. Da. Remainder into Q plus right. No. Plus elements include into Q. Elements are right at the Q. I have not subtracted. Eh? It will be right over there. Will we be able to submit it now? Oh, damn it. I'm not solving. So one question is remaining, and I'm not solving that today. I'm done for today. See you tomorrow.